So Leonard and I work for the Climate Corporation. The Climate Corporation's mission is to help all the world's farmers sustainably increase productivity with digital tools. So kind of a fancy word for software for farmers. And it's actually a really cool space to be in. And we're going to talk today about our experience trying to implement CI/CD in our rapidly growing software development company. So first of all, let me just talk a little bit about Climate. It's a subsidiary of Bayer now. We're just became a subsidiary of Bayer just a couple of weeks ago. We have Climate itself has approximately 600 employees, spread between Seattle, San Francisco, St. Louis, a small office in Chicago, Tremont, Illinois, Brazil, and then we have a smattering of really small offices in Europe. So we're now global. We've just gone. We just came out with our European launch a month or so ago. We actually, that was the second European launch. We did our first European launch several months ago. But we're available on the web, but we also have an iPad version that's got quite a bit of functionality in it, an iPhone version with more limited functionality, and also an Android version that's just on the small phone device. Our main customers when we started out, our main focus has been individual farmers or small farms or medium-sized farms, mainly in the U.S., mostly corn farmers. We are expanding now into other crops and also to dealers, and now that we're getting into Europe, much larger. They have much larger. They've got these huge mega farms. I need to turn off my thing, either that or. I didn't realize that it would go off so quickly. I guess when I'm on my computer, I'm always typing. All right. We also have gone from really coming out with the product that's our flagship product now, Climate Field View, for the first time in 2014, to being one of the dominant players in the industry now. So, and then Leonard is going to talk a little bit about the climate history. He's been there longer than I have.
Climate actually got started as a company called Weatherbill. A couple of smart guys asked a question: what can we do with big data processes besides sell ads? And one of the problems that they came to become interested in was, what can we learn about weather? What can we learn about rainfall? What can we learn about the impact on people? And can we make money at it? So they started actually selling weather insurance and using big data to analyze weather patterns all over the United States. If rain was impactful on your business, they could tell you, maybe a rainy day cost your business $10,000 or $100,000. They could formulate a reasonable strategy, a reasonable pricing for an insurance policy that would compensate you if it rained on any particular day or if it rained a certain number of days. The U.S. Tennis Open tournament that just finished, we had a rain-out policy that was written for them that was priced on our platform for over 5 years. The thing that they learned after a few years trying to sell weather insurance was that weather matters a lot to farmers. It's the #1 cause of crop loss, whether it's heat or rain or cold or what have you. It's a huge impact for them. So they began to specialize in agriculture, bringing big data to the agriculture business, learning about the agriculture business. We still sold insurance, but increasingly with all that information and machine learning capability that we had, we realized that there was a lot more value that we could offer to farmers. So that's our background. A few years ago, we actually sold off the insurance business and have focused strictly on products that help farmers farmers really optimize their production, starting in North America, but as Joy said, we've expanded into South America. We're now, all of our systems run in Amazon Web Services. We're primarily a microservice architecture. We do have a web-facing component, and we do have mobile components. So now we're going to jump into continuous integration and continuous delivery, because that's really what our talk is about. But I want to start with just a question for people here, like, who's heard of continuous integration? Show of hands. Virtually everybody's heard of continuous integration. No surprise, term that came out almost 30 years ago, and it basically means checking in your code maybe several times a day, several times a week, but definitely not big bang integrations, right? It's a great concept, it's made a huge difference. What about continuous delivery? Who has actually heard of continuous delivery? And of those hands, keep them up. Who is currently using a continuous delivery process where you work or someplace else? Any more hands? Maybe one in the back? Another one over here. Okay, great. I attended a conference about 8 years ago, asked the same question. There were like 55 people in the audience. Very few of us raised our hands. So it's good. It's getting more adoption. A definition that we're going to stick to today is that continuous delivery is the ability to get changes of all types, including features, configuration changes, bug fixes, experiments into production or into the hands of users safely, quickly, and in a sustainable way. One last term, because sometimes people use these terms interchangeably, continuous deployment. I'm going to skip right to a definition, which is just simply to actually deploy those changes to production. Continuous delivery is the ability to do it. Continuous deployment, actually deploying.
So, when I started at Climate 4.5 years ago, we were a startup company. Our focus was on first to market. We had to be first to market so we could get market share. There was very little attention to quality. We had really very, very few quality assurance engineers or testers on staff. We had very little automation, not even our BBT set was automated. Almost everything was tested manually. We didn't even have any written test cases. It was basically just exploratory test, and if you don't find anything, then we can ship. And we had no test management tools and really very, very small tool set in general to test with. Cowboy coding was the norm. Developers deployed directly to the live site from their laptops. And sometimes they were used to working without a QA department, and so the PM would tell them what feature to build. They would build the feature. They would tell the PM the feature's done. The PM would run through a happy path and say, "Yeah, it looks good to me. Let's ship it." And it would go on then from the developer's laptop off to the live site, and here we go. So as you can imagine, there were lots of live site events in the early days. And, we flip around pretty quickly and get those fixed. Most of the people were pretty good, but obviously we needed more discipline. The deployments were a manual process, so they were obviously fraught with error. They were complicated. The test environments were often unstable because we had all these different people just putting their whatever they just coded into the main branch and it'd be onto the test environment, and then suddenly everybody's broken and nobody can test, and then they're wanting to ship and you still can't test anything. You don't know if the software works or not because you can't test it. There's also, and this is true I think of most startups, there was almost no documentation. Everything was tribal knowledge, and so as we were trying to grow rapidly and add people, it really became a bottleneck because until somebody had time, somebody that knew what was going on had time to tell the new people what was going on, the new people could not get a whole lot done. We had a rapidly growing monolithic code base, and no standards in place, no written standards certainly in place. The one thing that we did insist on, thank goodness, was peer review of all check-ins. So no check-ins were made without at least somebody else on the team looking through the code and saying, "Yeah, it looks good to me." So one of our dev leads at the time was really gung-ho on CI/CD, and he wanted to try it. And a lot of us were pretty skeptical. But his premise was deployments are painful. If we deploy every day, we'll force ourselves to fix all the issues we're having with deployment. And one of our complaints in testing is we're spending all of our time doing deployment testing. We're spending at that point in time probably 50+% of our time doing deployment testing. And with all the other stuff we had to do, that bug regression and everything else, there was very little time to actually automate to get ahead of the manual testing grind. So, well, most of us were pretty skeptical about it. But he managed to convince senior management that that's the way we should go. So one day, we're just, boom, we're going to deploy every day at noon. So, or no, every day at 1 o'clock. So every day at noon, we would have this go, no-go meeting. And the meeting would go like, well, are we ready to ship? Well, we haven't been able to test because the environment's been broken the entire time. And then, okay, we'll get the environment fixed and we'll meet again at 2 o'clock. So we meet at 2 and it's like, are we ready to ship? Well, once the environment got fixed, we found these 3 bugs. We're working on fixing them. Okay, we'll meet again at 4 o'clock. 4 o'clock, it's like, so what, finally by like 6:30 we would actually ship, and then if there was a problem with what we shipped, we'd be there until 8:30 or 9 o'clock at night trying to unravel the problem, cherry pick things onto the live side or off the live side to get things stable so that we could go home. So it was, and testers went from spending like 50+% of their time to virtually all of our time doing nothing but manual testing to try to make sure everything was okay. So it was pretty much a nightmare for me. I was considering asking Quardev to find me a new job. I was a contractor with Quardev at the time. Luckily, after about 6 weeks, management said, no, we're cutting this, experiment. We're going to do other things now. We're not going to release every day anymore. And all of us breathed a collective sigh of relief. So the main things that went wrong are the things I've already talked about. The things we did not have in place, partly because of the startup mentality and the lack of actual test staff. Unstable environments, no test automation, unstable code base, this huge monolithic code base, difficult deployments, rollbacks were really difficult, and feature date-driven releases led to mounting tech debt. So let me talk about that for a minute. We do software for farmers. Farmers do things on a seasonal basis. So if you have a software that is for their planter and you don't have it done in time for planting season, then you might as well go home, because or drop back and sell it to them the next year. So we were always driving we have to get this done for planting, we have to get this done for harvest, we have to get this done. So we were always pushing to get things done by a specific date. We couldn't really slip the date much further, and even though we would try to set the date well in advance, somehow we would always slip right up to, we need to get this out because farmers are starting to plant next week, So that led to us cutting a lot of corners just so that we could get the product out the door on time so it would be useful to the farmers. And then we ended up accumulating a lot of technical debt, which was difficult to deal with. So roll forward a year or so, after we gave up that experiment of daily releases, management still believed that continuous delivery would increase our velocity, improve the reliability of our code base, and decrease environment instability. And most of us agreed with it in concept. My argument was we need the infrastructure in place in order to do it. But meanwhile, several things had happened. It was, say, a couple of years later. Climate had refactored our FieldView product to a microservice architecture. So everything, it was not this huge monolithic thing. The different teams were relatively independent. We could ship services separately. We didn't all have to release at the same time, which made it a lot safer to release because you're releasing a much smaller set of code. Each team kind of owned their own delivery, so the team started doing their own things. So at that point in time, some teams started to experiment with CI/CD. We put a new CEO in place at this point in time, and he really helped drive us from the startup company to a more mature company, and get everybody focused and moving in the same direction. He was the one that made the decision to sell off the insurance side of the business, which I think was a great decision because it gave us just a lot more resources to use on developing our farmer software. We also hired a director of test, and that helped with the corporate culture. The corporate culture was used to not really having many testers around at all, and the few that they had were, so few and far between, we really couldn't make much of a difference. And so he came in, he expanded the test team, he gave credibility to testing as a discipline that we hadn't had before. And he also helped instill discipline into both the test team and the development team to follow best practices. And then more recently, and I'll credit Bill, our director of test, with this, but also the new CEO, who's not really new anymore, Mike Stern, and probably Brian, who's between them, Brian Zimmer, our VP of engineering. The last year or so, one of our main focuses of the company has been on quality. So before that, earlier the focus was on we need to get to market as fast as possible to get market share. Now we're on farmers don't like it when their software is buggy. We need to make sure that we have a stable live site, and then we're delivering what we need to deliver to make our customers happy. Oh, and one more. Okay, so I've already mentioned the maturity. One more thing that we've recently done, which I think has helped to a certain extent, is we've prioritized the things we have to do. So we've got this big list of every single project that the company would like to do, and the executive team meets and figures out what is the most strategic, important thing for us to do first, and where do we put our resources, because we obviously can't do everything. And one of the things that has made it onto this list, and I think it's the only thing on that list that is not either a product or something like release in Europe, is CI/CD. It's the only actual development initiative that's on this list, development improvement. So, and it's actually very high in the list. It's been in the top 6, I think, for the last year. So that has helped, I think, to a certain extent. So now we're going to step away from our experience a little bit to, well, why would you do CI/CD in the first place?
So if you read the literature, there are a lot of promises are made or proposed or suggested, the benefits that adopting continuous delivery might bring to your organization. Some of those include reducing risk. A lot of us here are test engineers, SDETs, testing people, and I think most of us, when someone tells us, okay, we're going to go faster, our immediate thought is, oh great, that's going to reduce our risk, right? But that's one of the promises that continuous delivery offers us. Just delivering value faster. That's obvious. If we do this more frequently, we're going to deliver things more quickly. Actually gaining higher confidence in our products, the quality of our products, and even in our own teams. It actually proposes it can lower the overall development cost, the cost of releasing products. And these are all pretty bold claims. You're going to deliver a better product overall, and your teams are actually going to be happier. So there's the pie in the sky. We're going to do this continuous delivery thing because we're going to get all these benefits.
So I said we were going to try CI/CD again, and how'd that go? Well, we tried it. We got a CI/CD champion assigned. We defined what the activities were going to be. We set the schedule. We're going to ship in August of 2017. Everybody is going to be fully CI/CD all the way across the board. And and then we roll out this process. Well, and then we, a few months later, we got a new champion assigned, we got new activities defined, we reset the schedule again, and we maybe rolled it out again. And I remember we've reset the schedule probably 6 or 7 times, and we still don't have everybody on CI/CD. In fact, we're quite a ways away yet, but it's been quite a process of trying to get there. We have been making progress, but it's been a lot slower, I think, than most of us would have liked.
So one of our challenges has been, like, what exactly do we need? When you tell a team that hasn't heard of continuous delivery, okay, you've got 12 services, you're going to get them all moved into continuous delivery pipelines, go. Different teams, as Joy mentioned, they're fairly autonomous. They have their own staff, they have their own management, they've got their own feature set, they've got their own product owner, they've got their own backlog. When somebody comes in and says, okay, yes, and you have a corporate initiative, and so you also need to do this in a continuous delivery way. Some teams throw up their hands and say, we don't really know what that is, we hope it goes away. Other teams, maybe they understood it, maybe they've already stuck a toe in the water and they've experimented with it and have some sense of what to do, and they just go. So we did have to come to some common definitions across climate, and this is basically what our current working set is. For a service now, I'm going to pause for a second. We do practice continuous delivery for many of our web application components. We are moving our mobile applications. Joe, who's here from our iOS team, and our Android team are also moving towards a continuous delivery type of model for their products. Mostly we're going to talk about services for the rest of this talk. So moving our services from our legacy architecture, which was EC2, individual server-based deployments, into a container-based deployment. So that was one of the big cost savings, improved scalability, probably improved security. We had a sort of parallel initiative to move off of legacy EC2 instances and into containers. So that was kind of a gating criteria to get onto the CI/CD maturity scale, if you will. Each team, each service has to have a completely automated build pipeline, so that when a developer has pushed up a code change, their PR has been approved, it gets merged in and automatically deployed, at least as far as our pre-production environment, optionally as far as our production environment. That means all critical testing must be automated, and they must have a push-button deployment to production. As Joy mentioned, our tooling allows developers to actually push what they're working on to production. We strongly discourage that now. Just to kind of give you a sense of like how this starts to look when we communicate it internally, we've got some diagrams that kind of help inform teams that say, look, there's basically 4 stages to this. I'm going to have to read about the big screen over there. Stage 1 is is the environment that a local developer works in, what steps they need to do. That's static analysis, that's unit testing, that's running integration tests locally on their machine. That's before they do a PR pull request. And then they push that code up. We do a pre-merge unit testing check so that eliminates builds being broken. With each change that a developer pushes up to a PR, that code is being integrated into our main line on a separate branch, and unit tests are being executed in most cases. Once that PR is merged, it goes into the master branch. We're hit stable on almost all of our services. And then that starts off the actual build pipeline. Code's merged, we do some analytics on it, and then we deploy it to our lowest testing environment, and we begin to run our suite of automated tests. If it passes
and we also do exploratory testing.
Yes, if it passes those tests, then it can get promoted. It will often get promoted into our pre-production environment if that pipeline and another suite of tests are executed. Very often that's going to be performance tests, scalability tests, things of that nature. There are activities that happen outside of the pipeline. Usability testing, long-running tests might happen outside of that pipeline. Certainly exploratory testing. We have lots of tests running in our environments at all times, and Common services are going to be hit by those tests as well, but the core pipeline is going to ensure that service has executed the tests that it needs, and the other activities can happen kind of out of sync. This is what a simple build pipeline looks like. We use Jenkins. It's perfectly adequate. We've got it running in a cluster containerized mode. We don't have to drill into the details here, but basically on the left side are our QA1 tests, and then push into staging, and then all the way out to production. So what are some of the challenges that we've encountered that have made it more difficult than we expected? Here's everybody's bugaboo in automated testing: flaky tests. If your tests are written to a web interface, even a mobile interface, if they're dependent on data being present when your test runs, if they're dependent on the system being in a certain state when your test runs, if you're dependent on all of the services being up, that can introduce flakiness. And we haven't slain that dragon fully, but we've made a lot of progress, and the tools are getting better, and it's just something you have to keep soldiering through. Data availability, which can be an issue for flaky tests as well. Database migrations, because we're still a very innovation-driven company, all of our new features require new tables in our databases, new data schema. You have to incorporate that into your pipeline in some way to ensure that those data migrations occur and allows your code to continue to deploy forward. We've had some issues with our internal tooling. We have a wonderful ops team. They build a lot of our deployment tools, but their requirements are different than our requirements in a lot of situations, and we have to negotiate on what changes they need to make in order for our systems to be able to fully convert to continuous delivery. Handling rollbacks, what happens when something actually goes wrong in production, making sure that everybody knows what needs to happen. We can do a fix forward type model in a lot of cases, but oftentimes when you're doing continuous delivery, you actually do want to just roll back, sort of stop, drop, and roll, figure out what actually happened, went wrong, what the fix is, and then redeploy going forward. The nice thing about continuous delivery is most of your deployments are happening during daylight hours. They're not happening at night. And so people are getting paged when they're at work, and there's other people around that can help them out. So that's one of the nice side benefits that we put. Yeah. Do you want to take Matt's question?
Yeah.
Oh, Leonard, thanks. No, I just wanted to point out that one of the things I couldn't squeeze into 15 minutes was that I solved the flaky test problem.
Yeah.
But we can talk after.
Yeah, absolutely.
Okay, so I think one of the biggest challenges we've had to CI/CD adoption across the company are the social challenges. Cultural inertia being a big one. People are used to working the way they work, and it's really, really hard to get them to change. And so one of the things that has happened in Climate for a long time is that marketing and sales has picked a feature set and said, we need this by next season, and thou shalt build it. And engineering was like, okay, let's go. And the problem is, because we've come up with a hard and fast deadline, it always takes you longer than you think you're going to. The thing that gets dropped is CI/CD. If you can do A or you can do B, you don't have enough time to do both of them. A is going to get your product in front of the customers, get money coming in the door. B is going to make you faster in the long run, so B is important to do, but you can put B off. You have to get A out now. And getting people to carve the time out of their schedule to do CI/CD has been really, really difficult. It's so easy to deprioritize the working on the tools that are going to make you faster rather than the product that you're selling to the customer. And it's a hard balance in any case. I think in any company this is a difficult balance to strike. But if you never invest in your ability to go faster, then you're going to have a really hard time staying competitive, in my opinion. So to try to drive that knowledge back up the chain and out into the program managers and even the salespeople and say, look, you guys need to back off on all these features and give us time to get, to have a solid foundation, to have a good set of tools so that we can move forward at a faster pace. So we're still struggling to push back on product and marketing on all the features that they want to go out the door. And then for those that actually did CI/CD and have gone that direction, there's still pushback from them of, well, if we push a button and it goes all the way to production, then something bad might happen. And you really have to get them to think about it and come back with, well, why do you need 24 hours in the pre-production environment before you go to production? What do you find out in that 24 hours? And then they'll, oh, well, there's this job that runs overnight that sometimes causes trouble. So then you can build a test for that so that you can go all the way to production. So we'll talk about where we're at so far. We are approximately 72% complete, although complete is kind of an ambiguous term in this case because it's really hard. If somebody says, yes, we've got our unit tests done, we're still not saying what, well, we actually are tracking the percentage of coverage that they have, but we're not insisting that that they hit a certain percentage of code coverage with the unit test before we can check mark that yes, they've got their unit test done. Right now our requirement is that they have their unit test done. And at some point, we're hoping once more people are on the, once things are green across the board, then we can tighten things up and say, okay, now we want you to have this level of code coverage on all of your unit tests. So I'm going to show you, I don't think, let's see, how do I escape out of here? Well, I think that's going to bring me out and hook me to the live one. Wait, I want to go back. And I want to, see, yeah. But I managed to escape out of it. So, there we go. Okay, so this, I've pulled a bunch of data out of this, but this essentially was this giant spreadsheet that we've been using to track which services, most of these are services, you can see all the way across the board, service. We've got 112 of them, roughly. Well, there's 113 in the list, but I noticed a couple are inactive. So we have a link to where the Jenkins pipeline would be that I deleted, a link to our alerting system, that everybody have these filled in, a link to the console that keeps track of a link to their Jira projects. It's a service, who the engineering managers are, who the director is, what the status is, and then all the way across the board, here are all the pieces that here are all the pieces that we need to have in place. So, this is, full continuous integration. We're on, everything's on the new build system. We've got unit tests. We've got test in QA1 environment, test in staging environment, test in production environment. Here's the code coverage number. Notice it just says unit coverage. That's, are you reading your code coverage? A lot of people just answered yes. Some people put their actual code coverage percentages in there, which these should all be green as well. It's only the blank ones that should be red that aren't showing up as red. And then we've got the, who is full CD here as well. And that, we also have commit dates on these things. Notice nobody's committed there. And we've got automatic promotion to staging, automatic promotion to production. So some teams, we only have 3 teams out of this, or 3 services out of 112 that are actually push button, goes all the way to production. But you can see we're getting there. One of the things I noticed when I was looking at this is if you start looking at things like the engineering director or the engineering manager, I think it's more director dependent, you'll notice that if you filter on a certain director, you'll notice, oh gosh, most of the services under him are green. you filter on a different director and you notice, oh, gee, all of the services under him are red. So it really seems to be, I think, almost more dependent on what kind of pressure they're getting from management, or you know, what their manager cares about, whether or not they've gone CI/CD than not. I've also noticed when I was looking through this that it seems to be the more technical managers, the managers that are really hands-on, that really kind of know what's going on, that are more likely to be to have CI/CD implemented on their teams. The managers that are more maybe process-oriented or political tend to care less about CI/CD. So it's just kind of interesting cultural observation. Let me back to my slide. So, I mean, it seems disappointing that we only have 3 that are completely done. We've got a lot that are well on their way. At the same time, we're building more and more services. Most of the new services, well, I shouldn't say most of the new services. All the new services, I happen to be working with a team whose manager has embraced CI/CD, so, and we've gotten really good. One of the things that I would have liked to have shown on this slide are metrics that would show you how much faster we've gotten from when we were mucking around and having a real struggle trying to deploy to where we're at now. We're the team I'm on now, where a lot of our services, all of our services are CI. Most of them are at least partially CD. And we do put everything in production well before we open it up for customers to look at. So, we don't have the metrics. We were way too busy, and it was way too chaotic in the early days to track metrics like how fast are we delivering. And we're just now really getting all of our metrics implemented as our company matures. So, and it's been a pretty fast ride. I've been there 4.5 years, from, you know, B1 to just struggling to mature to where we're at now. So Leonard and I were talking, well, maybe we should do a phase 2 talk in a couple of years, you know, where we're at then.
So we start early. That's one of the benefits that we get. Some of our legacy services that are really critical, they've been the most difficult, even though their unit testing coverage is high, their API testing coverage is high. There's just this like knowledge of what can go wrong, and it's difficult to mitigate it, and so some of those services have lagged a little bit behind some of the others as far as getting to CD. Be pragmatic about automating tests. Automate enough of your tests. Don't worry about 100% coverage. Just keep thinking about whether it's a critical test, whether it's something that should be part of your pipeline. If it's something that's important that can be done outside the pipeline, go with that. Yeah. Unit testing is something that comes in. We had a slide, we took it out. How much unit testing is enough? Again, that's a decision that teams can make. Deploy dark, that basically means go ahead, deploy your service out to production before anybody's using it. If it's a UI feature, have it behind a feature toggle. Give yourself the ability to practice deploying that code, and try it in production by flipping that feature toggle or joining that account that has as part of a beta cohort, and gain confidence. Make sure that your monitoring and alerting are all really effective. This is something Climate's very good at. So when something goes wrong, generally somebody gets notified and they know what to happen. They know what to do about it. But that's really essential. Make small bets, make small changes, and deploy those frequently. Don't make big bets if you can help it, or break them up if that's the challenge. And then you just learn and gain confidence as you go. The more you do it, the more comfortable it is, and the more aware you are. Things are going to go wrong. You are going to get paged. You learn from that experience, and you realize, like, okay, we know what to do when something small bad happens in production. And pretty soon, people start to trust the tools. They start to trust their tests. They start to ask the right questions, and they just become a lot more comfortable with the process. So again, kind of anecdotally, those teams that are doing this, we do feel like we're reducing risk because we're making those small changes, and we do it all the time. So our practices, our procedures are well understood by everybody. Nobody is trying to remember some incantation to how to deploy to production, or it's their first time. It's all automated. We definitely deliver things faster, particularly bug fixes or responses to external events, API changes. If some client needs something done a little bit differently or needs a little bit extra information in the response code, we can make those changes much more quickly and much more reliably. We've gained confidence in our overall systems and our procedures and our teams. Actually, and from a management perspective, I'm not a manager, but managers say they have more confidence in teams that are doing this because they have a more predictable workflow. Like to think we're lowering the cost. There isn't a similar team doing it the other way, so you can't really do A/B measurements, but we feel like we're delivering more value for the same amount of effort. And we think we're delivering a better product. And most importantly, most of the teams that are doing this are pretty happy with it. Once they've gotten over the hurdle, they're glad they've done it.
We're definitely in a much better space than we were when I started on it, as far as people being frustrated and trying to pull their hair out every time we deployed. So what are our next steps? You saw that we still had quite a bit of red across the board. So I went and interviewed my boss, who's the director of test, who's now the one that's pushing the CI/CD across the company. And I said, well, what's next? What are we going to do next? And he said, well, we're going to hire an outside company to come in and interview engineering managers. We're going to ask the successful teams, how did you do it? What enabled you? What were the key factors that made it easy for you to do this or made you able to do this? We're going to ask the teams that aren't doing it, why haven't, what's blocking you from doing this? Why haven't you done this? And he wants to get an outside company to do this so that people will feel free to tell them whatever they want to tell them. They won't feel like they have to be, say the right thing or be, political or so that should be interesting. The other thing that's going on in parallel is we're building tools and processes that will help teams adopt CI/CD. For example, we're making Jenkins pipeline templates that when you start a new project, you can just pull in this template that, if it matches essentially what your service is like, then you'll be able to use the template to go from there instead of having to build everything from scratch each time. And of course, continue to push quality engineering as part of our cultural DNA across the company. And that's it for our presentation. We are happy to answer questions.
Cool. I'm curious about the last slide. The term quality engineering. Would you define that, please?
Who wrote that? Was that me or you?
I think your boss wrote that.
Maybe. That might have come from my own.
Basically, it's right. It's make sure you're doing your testing. Make sure you're doing all the testing that you can.
Okay.
We are still in a very innovative space. We're still, I'm not going to say startup, but Climate doesn't have the advantage of watching some competitor figure out something. Like everything we do is new. And so there's a big challenge as to whether, how you deploy that and find out whether it's going to be of value to farmers or not. And so it's easy to focus on getting something in front of growers rather than getting something really great. And finding the right tension, finding the right balance is kind of a challenging thing for Climate. We're quality advocates, and so we want everything that goes out to be really high quality. And it's very important to our customers in order to build trust that our software actually works and does something that's useful.
Yeah, and I think he means it in the broader sense too, not just the QA team, but the entire development team should have a focus on quality, doing quality engineering.
And we have great engineers at Climate, so.
Do you give them a good talking to sometimes? You think they're like shortcut because they look cool?
Hey, Joey, I had a question. I like that Excel sheet that you showed.
Oh, yeah?
And one of the things that you mentioned is said, hey, we noticed that maybe different teams, like, okay, you guys are green, let's figure out what you're doing right, and okay, this one's going red. Have you drilled down to the service level on that? So let's say you have 100 and so odd services, and when we've defined the criteria for successful CI/CD, and then we see that these are met by a certain date, have you been able to correlate that to trending, saying, okay, if we do this, then we realize X in terms of sustainment, less issues and all that. Have you been able to go to that level? Because it certainly seems you're on the fringe of being able to show that kind of success tangibly because of the criteria you've set and defined it at the service level. Does that make sense?
I'm not sure exactly what you're getting at. I
So
will say
you've
that
got
the strongest
services, you've
trend
got
I've
a
seen.
grid for meeting
Yeah,
criteria
yeah,
about
yeah.
about targets along the CICD path.
You know, the strongest correlation I've seen is manager, but some of it, there are certainly services that some of it's dependent on the service as well. There's a comments column, I didn't read through the comments, but you can look at the comments, and some of them are like, well, our service, it, you know, does blah, 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 and some of them are, our service is internal only, which I personally think that should still be CICD. I mean,
Okay.
but there's also no one size fits all solution, and we're fully aware of that. Each team is going to need to adjust, or each service may implement things slightly differently.
Okay.
Did that answer your question at all?
It does. It answers your approach to it, which I wondered how you're taking that information.
Yeah.
Cool.
Some services are highly entangled with the rest of the climate ecosystem, and others are very independent too.
Right.
We have simple CRUD services, and we have really
True
complex
microservices.
model
Right.
execution services, and so that'll come into play as well.
So when you look at the goodness you have now, however you want to measure that, and over the course of this duration you've been working on this, how much of that goodness could you attribute to just the move to a microservices architecture?
Yeah, I mean, just to moving to microservice
Just in other words, if
architecture.
you only did that,
Yeah, there's no question you get a big benefit, you get a big
Yeah.
boost from that.
not to diminish the CICD.
No.
No, it's,
but with the automation,
we went to the microservice architecture before we really started going into CI/CD, and I think the microservice architecture enabled the CI/CD, because without that, I don't think we would have been able to do CI/CD, because as Leonard mentioned, each team has kind of gone at their, gone at their own pace, and Leonard and two of the devs of a team that he was on just got an award from the company for being the first. They have the only 3 services that are fully CI/CD. Were the ones that he worked on with those guys. So if we hadn't had a microservices architecture, I don't think we would have gotten nearly as far towards CI/CD. However, I will say just the microservice architecture did not get us to where we are today. The CI/CD definitely helped. And that's anecdotal evidence, but, I mean, I don't have specific, it's hard to quantify that kind of thing.
Right.
But just observing how quickly we can release now compared to, even when we just flipped to microservice architecture, we were still struggling until we got some of these other things in place. So.
we adopted build pipelines in some fashion as we started doing the microservice architecture. So, we started breaking apart a monolithic Ruby app that ran the company in the early days. It was kind of the presentation tier. And we did our user authentication, account creation, field selection, and all that kind of stuff. And we started breaking that up pretty early on because that was common functionality for the insurance business and the grower-facing stuff. And immediately once we started breaking out those other features, we started creating build pipelines, and that sort of got the ball rolling. Yeah.
How do you handle the culture? The culture, I find, I'm an architect, but that's part of the big problem. I have the technically oriented people in my shop who say, yeah, we have to have quality documents, we've got to do what we do well. But there's, even they are the, well, I've always done it this way.
Mm-hmm.
How did you folks approach the culture change to get more people on? Like, what was the, I'm one of your folks and I don't really care, but at the same way forever, how did you convince me to get on board?
Well, we've tried a lot of different things, and as I mentioned, I think this is one of our biggest challenges. One of the CI/CD champions we had basically had the flogging approach. Just he kept reminding you and putting JIRAs on your board, and and that really didn't work. I think what has worked the best is the teams that were the early adopters that were successful when other is spreading that information so that other teams can see, oh yeah, these guys are doing it and they, you know, they like it a lot. So maybe we should try it too.
So the Napoleonic Army concept of establish veterans and then spread the veterans out into new companies. I mean, or at least the knowledge that they have, or the feeling that, oh, that should work.
You know,
Actually, what worked for us was we hired new engineers and we told them they were going to do this, so they didn't. I mean, that's about 85%.
Well, that works too, right? This is how we do it, period. Yeah.
And I work with a lot of veterans, and they're still the ones that are like, no, not my service. Like, you know, it's been sitting there staging for 3 days. Why aren't you promoting it? Like,
right. But you had successful teams, and that smell of successful teams got around a little bit.
Yeah, it does. It does. And it isn't. People make it work. People are the reason why it slows down. So that's something that we just all have to remember. Is it's really a people problem at the end of the day.
Great.
All right, thank you guys.